Hello and welcome. Still going to talk about a little bit about control flow. So let's dive in right into loop repeating code. First, we are going to talk about this for loop. The for loop is going to be all about repeating code. So just as a reminder, repeating code is a way to allow for not duplication, and you are actually maybe executing more than one like code at a time. So the programming language has certain constructs designed for the language that you can use when you want to repeat code. And this allows you to repeat a block of statements until some condition is met. So it's similar to the for loop, and that's you are going to evaluate a Boolean expression, a condition. You can't run forever. When you run in a loop forever, that means it's an infinite loop. And these are only certain times you may want to do that. Usually, again, for like monitoring or listening to something. So the number of times that a loop is repeated can be controlled simply by account. These are two types of loops that you can do. A counter control loop or like a sentinel control loop is that they call it. A counter control loop means that the loop runs 10 times, 20 times, 30 times a specific amount of time. It repeats the same statement block inside the loop a number of times. You can have another type of loop where it's not counter control. It may run 5 times, it may run 100, it may want 20. It all depends on a condition, a variable or something. So for example, you can run a loop that says, I'm going to run my loop over and over and over until the user enters this. So until the variable changes to quit, it's not counter controlled. It's not dependent. Again, it may run 10 times, it may run 100 times. These are the two different types of loops. And so I will provide examples of both. But just think of this at the high level. When would I want to repeat code? Well, I may want to repeat code 5 times a certain amount of time, definitive amount of time, and I may want to put a code based on a certain condition entered by the user, and that's called sentinel. Our for loop has the for keyword. It's used to execute a given number of times. It's usually used for counter control, but it does not need to be. You can use it for counter control loop or a sentinel to control loop. It's up to you, but a lot of the examples in a lot of the practices is counter controlled a certain amount of times. If you want to display the numbers from 1 to 10, for example, you would use the for loop. You would not want to write 10 lines of code with the same printf statement in there displaying a different number. That's very inefficient. It's very time consuming. You would use for loop to repeat code, but what you would do is you would do something like this. Here's an introduction to what the for loop look like, the syntax. You have the for keyword and then you have these parentheses. Again, the parentheses identify different things that are going on for the for loop. Then you have a bracket and you have statements inside the bracket. So again, the bracket represent the body of the for loop. Just like the bracket represent the body of an if statement. If you have one single statement in there, you don't need the bracket, but good practice to always use them. So in this example here, you see for keyword, what should be the first thing you identify? The operation, how long it's going to run is controlled, and what appears between the parentheses. After the for keyword, which we are going to do, go into specific detail, there's basically three different expressions are there. And you can recognize them because they are separated by the semicolon. So the semicolon says this is an expression statement. So what are those three things doing? We are going to describe the action that you want to repeat inside the body of the loop. That's what happens so many times. In this example, the body of the loop is printf. So if a condition is evaluated to true, it will keep printing that number. And again, for single statement, you can omit the braces. So let's go through this in detail. The general pattern for the for loop is you have this type of statement. You have a for, and then you have a starting condition. This is pseudocode. I'm trying to describe the for loop here. So the starting condition is the first thing, everything before the first semicolon. The second thing is the continuation condition with a semicolon at the end, and then the last thing in the between the parentheses is action per iteration. And I want to describe each one of these, and then after that inside the body the loop statement. The loop statement is pretty easy. That just inside the body, that's the code that's going to be executed, that's repeated each time. That's pretty basic. And again, you can either have break it braces if you have multiple statements, or omit the braces if you have a single statement. The starting condition, that first thing inside the parenthesis before the first semicolon is usually, but not always, it usually initializes a variable called the loop control variable. That's the variable that you are going to start at looking at each iteration. So the loop control variable is typically a counter of some time, not always. Again, I want to emphasize that it does not have to be, but a lot of times in a for loop, it's counter, and it tracks how often the loop has been repeated. That's what this starting condition and the loop control variable is doing. You can also declare and initialize several variables of the same type here with the declarations separated by commas. So you can have multiple initializations here. Now, depending on what C compiler you use, you may not be able to declare those variables inside the for statement. If you use anything below the C99 compiler, you have to declare the variables outside of the for statement, and then you would just initialize them in this where the starting condition says. But we will go through some of those examples, but the starting condition is where you initialize variable. It's the loop control variable, and it's named for that region because it controls how often the loop is going to execute when you initialize it. The next thing I want to talk about is that continuing condition, continuation condition, the part that's before the after this first semicolon in the for loop. This is a logical expression. This is the condition that's going to evaluate to true or false. This is when you are going to jump in the loop or exit the loop. This determines whether the loop should continue to be executed. As long as this condition has a value of true, the loop is continued to execute. All the statements in the body are going to get executed. This will typically check the value of the loop control variable. So you initialize the loop control variable in the starting condition, and then you look at in the continuation condition. You can put any logic or any arithmetic expression here as long as you know what you are doing. The continuation condition is tested at the beginning of the loop rather than at the end. This is referred to as a pre-test loop. You will notice the difference when we talk about the do-while loop, which is a post-test loop. But what this means is that the loop statement may be executed once, it may be executed 0 times. It all depends on whether or not that continuation condition evaluates to true or false. If it evaluates to false, you are never going to execute the body. If it evaluates to true, you will execute that body at least once. The action per iteration, which is at the very end of the for loop after the second semicolon, that usually does some kind of modification of the loop control variable. It will increment or decrement if it is a loop counter, or if it is a sentinel loop, it may ask the user to enter more input. You can also do more than one modification of a variable. You can modify the loop control variable, and you can modify other variables. You just have to separate them by commas. But to summarize everything I said, we have this little table that describes that. But before we talk about that, let's look at a little example. So here's an example. We have the for keyword, and then you will notice that we have int I equals j equals 2, I equals 1, j equals 2. That's where we initializing variables, and we are actually initializing two variables here separated by the comma. Typically in a for loop, usually just initialize one, the loop control variable. But in this case, we are initializing I and j. And then after that semicolon, we have the condition when we are going to enter and whenever we are going to exit this loop. Whenever we are going to enter, as long as I is less than equal to 5. That's our Boolean expression evaluates to true or false. And then after that, the second semicolon, we are going to modify that loop control variable or any other variables we have concerned it. Here we are doing a plus plus. I think this is an incrementation operator prefix I, and then we are assigning j equals to 2, j plus 2. That's going to be actually your x condition, modifying that loop control variable. And then the body of the loop just has a single statement, so we don't need the brackets. We are just printing out the value of I times j. So the output produced by this code is going to be the value 2, 8, 18, 32, and 50 on a single line. The first iteration of the loop, I is going to be equal to 1, j is going to be equal to 2, and so it's going to say I times j, which is 1 times 2, and it's going to display it's going to check to make sure I is not greater than 5, I is not its 1. So it's going to go back and execute a second time. And we are also modifying that variable I in our last statement. So in the second iteration of the loop, I is going to be equal to 2 and j is going to be equal to 2 plus 2, which is 4. So now we are going to multiply 2 times 4, which is 8. And we are going to display it, and then we are going to check, is I greater than 5? No, I is still 2. So we modify I to now be equal to 3 for the next iteration, and we modify j to be equal to 4 plus 2, which is 6. And then for the third iteration of the loop, we multiply I times j. So we say 3 times 6 and we display 18. Before we execute the fourth iteration, we check to see if I is greater than 5. No, it's 4. Then we increment it, we say it's 5. It's equal to 5, or it will still run. Then we'll do 32 and then we'll do 50. So this is a statement. You want to run this and execute it in the code browser and play around and change things. But what we are doing here is we are doing three separate things on a single line of code. We are initializing the loop control variable or any other variables. We are having our Boolean expression after our first semicolon, our exit condition, and then we are modifying the loop control variable and any other variables we want as that last part of the for statement. So to summarize what we are doing, I found this nice little handy chart from a book and I want to show you. This summarizes everything. The first semicolon initializes the loop control variable. After the first semicolon, we are doing our condition, our Boolean expression, and then after the second condition, semicolon, we are modifying that loop control variable, and this is the typical example you see. This is a counter control loop that starts at 1 and goes all the way to 10. So this is going to actually execute 10 times. The key being there less than equal to 10. So you are going to see relational operators as 4 conditions, just like we saw relational operator as our conditions on our if statement. The key here is you want to modify that loop control variables or you are never going to execute it. So the plus plus count is very important. And as far as pre or post incrementation, whether that plus plus is before the variable or after the variable, you don't have to worry about it because it's only going to get incremented or decremented after the iteration of the loop. So it doesn't matter if you do plus plus count or count plus plus. And also, again, depending on the version of C that you are running for your compiler, you may be able to declare the variable count inside the for loop, or you may have to say int count equals 1 or in count outside of the for loop and then initializes it in the first semicolon. C99 added the initialization of declaration in the same part of the for loop. But this is basically how for loop works. Now, let's go into a little example. I want to show you the flexibility of the for loop. Here's an example where we are going to basically just some integers. And in this example, we are going to ask the user enter the number of integers they want to sum. We are going to store that in a variable called count. We are now going to have a for loop that goes through all of these. Depending on the number they entered, iterate through that many times. So here we say for we have unsigned int doesn't not have to be unsigned. For int I equals 1, we are initializing the loop control variable, and then we are saying if I is less than to count, that's when we are going to execute. Then we are going to modify the loop material plus plus I. So this is going to run again the 1 to however the number the user entered, 10 or 20, and all we are going to do is we are going to say sum equals sum plus 1. Now the for loop is so powerful because the for loop allows you to modify many variables. We don't even need to put that sum plus equal I in the loop of the for loop. We can put it at the end of the last statement. So in addition to incrementing I by 1, we can just say sum plus equals I plus plus. So we did everything in a single line of code, and that shows you the flexibility. It's all because we can modify the variable. in the for statement itself, we don't have to have that line of body. So let's take a look at this example in our code blocks to show you how you can manipulate it and see what the output is. Here is our example that we had in the lecture. I want to go ahead and try to compile this. And when I compile this, you are going to notice that I have an error. It says I cannot declare my variable inside my for statement. This is because I am running an older version of the C compiler. I'm running the C89. You probably would not have this. But to solve, if you ever see this type of error, all you have to declare it outside of the for loop. So you just say unsigned I, and then inside the for loop, you initialize it something like this. Now let's try to build, and I just have to get rid of some of these format specifier. So when I compile successfully and I run this program, you are going to see how the loop works. It's going to ask me to enter the integers I want to sum if I enter 5. It's going to sum up 1, 2, 3, 4, and 5, which is 15. And what we could do to debug this is we could add a bracket to the for loop. And we could want to just see how many times it runs. We can add a print statement. Not to necessarily debug it, but just see what's going on. We could say inside loop, and this will tell us that the loop runs 5 times because it's going to run I to count. So what I want to demonstrate is how many times this is running. So now when I build it and I run it, I'm going to see what's happening for each iteration. So I'm going to, I say 8 inside loop. Inside loop, I didn't add a line feed, so it's tough to read. But inside loop is displayed 8 times. And then I sum up each of those numbers inside loops. So the answer is 36. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So you can play around with this. But again, we initialize our loop control variable. We check the condition to exit. We are going to exit once we hit whatever the user entered. If the user entered 8, we are going to run 8 times. And then we have to modify I. If we didn't modify I here, you had have a forever loop. And what would happen when you run the program? It would run forever. So you had see after you entered the number, your program will never exit. So say we enter 6, I hit enter, look at what's going on. Just printing loop inside, it's never existing. It's an infinite loop. So that last thing is very, very important. You always want to modify your loop control variable. And again, the loop control variable determines the exit in this case, I. So the for loop is used quite a bit. It's very easy to use and it allows you to do 3 different things inside of loop. Initialize the loop control variable, check the loop control of variable for the exit condition, and then modify that loop control variable. Those are 3 things that you have to do in a loop and you can do in a single statement. Now let's me talk about the infinite loop real quick. So I just demonstrate an infinite loop. This is where you never exit. And you have no obligation to put any parameters in the for loop statement. You can actually write an infinite loop on purpose. The way that you would do that is you would just put the semicolons in there. So you would have a for loop with 2 semicolons. If you ever see that, that means you are writing an infinite loop. Now, typically, you would not want to have infinite loop, but there are times because the condition for continuing the loop is absent. The loop will continually infinitely. This is sometimes useful if you are monitoring data. So if you are monitoring data, you might have something in there. Typically, when you have a for loop, you usually also have a sleep, which will pause execution of the program maybe a second. So you are monitoring something. The other use case where you might have an infinite loop is you are listening for a connection. So if you are waiting and you are listening for a connection, or if you're pulling something to see something, you may do that. Now, some people argue that you should never pull and you should never listen, but that's hello and welcome. In this lecture, I would like to talk about the while and do while loops. We have talked about the for loop, which essentially allows you to repeat code. There's other construct in C called while and do while, what do the same thing with just different syntax. So the while loop is a mechanism for repeating a set of statements and it allows execution to continue for as long as the specified logical expression evaluates to true. So more of the same here, just like if a statement will execute certain code, while a statement will execute certain code based on a Boolean evaluation a number of times, everything you can do in the for loop, you can do in the while loop. It's just different syntax. So what the while loop looks like is something like this. At a very high level, if we are looking at pseudocode, while the condition is true, keep on doing this. So to relate it to a more world example, basically while you are hungry, eat sandwiches, something like that. So you are going to repeat code. You are going to keep eating many sandwiches while you are hungry. The general syntax for the while loop is as follows. And this is showing you the syntax for one statement in the body. So you don't need to provide brackets or curly braces. I tend to use the terms curly braces and brackets in the same terminology. So here is what the syntax looks like when you have one important statement, multiple statement. You have to have those brackets. Single statement, you don't. They are optional. You can't have them, or you don't have to have them. The expression goes inside the parenthesis, just like the for loop. And the if statement, the expression here is different from the for loop in that it's a single exit condition. It's just the expression. You don't initialize the loop control variable. You don't modify the loop control variable in between the parentheses. It's just the expression, just the exit condition. The condition for continuation of the while loop is tested at the start. So this is top of the loop. So what this means is it's pretest loop, pre-test loop. And what that means is it could execute 0 times or it could execute multiple times in the body. And again, this is going to be relevant because the do while loop is doing something a little different. If the expression starts out false, none of the loop statements in the body are going to be executed. So that's why it's at the top test. So if you answer the first question, no, I'm not hungry, and you are ever going to eat any sandwiches, you are going to move straight on the coffee or the next line of code. You are not going to enter the body of the loop if the loop condition start out as true. The loop body must contain a mechanism for changing this if the loop is to end. Otherwise, you are going to have an infinite loop. So with the for loop, where you modify the loop control variable in a single statement, it's the same thing in the while loop, except you have to do it in the body. The while loop is going to initialize loop control variable somewhere, and then it's going to modify inside the body of the code. So as I mentioned, the while loop can do everything a for loop does. It just different syntax. And again, the for loop is shorter. You can do everything in one line, whereas the while loop have to do those three things on separate lines. So in this example, if we have int count equals 0, this is the loop control variable. This is outside the while loop statement. If you were using a for statement, this would go inside the for loop as before the first semicolon. That's where initialized loop control variable. Then you have the while keyword, and you have inside the parenthesis the Boolean expression. This would be equivalent to the for loop, the second statement right before the second semicolon. So this is what you check for true or false. And it's a true or false, you enter the body of the loop. If count is less than equal to 5, then you are going to print out the count. The next line of code after that is very important. The plus count, because that's modifying the loop control variable. Because the condition at the top saying if the count is less than equal to 5, if the count is always equal to 1, you have an infinite loop. So that plus count very important. And plus count, remember, is an incrementation operator. It's just saying some count equals count plus 1. So this loop is going to run 5 times. It's going to run with count equal to 1, count equal to 2, and count equal to 3, count equal to 4, and count equal to 5. Once count is equal to 6, it's going to jump out of the loop, and it's not going to exit any other statement in the body. Again, you should be thinking in terms of the for loop. It's just a loop control variable and the modification of the loop control variable. It's not in the declaration of the actual loop. It's not all in one line like it is in the for loop. Here is another example where the logic is controlled to the end of the loop. So in that first example here, what I showed there, this is a counter control loop. It's going to always execute the same number of times, which is 5. In the next example, this is an example where the loop may execute 100 times or 0 times. The condition that we are evaluating here in our while key, where num is not equal to -1, is all dependent on what the user enters, because num is what the user enters. So this loop may execute 0 times, it may execute 100 times. It all depends on the input from the keyboard. And this is called a sentinel control loop. It's not counter control. It's based on logic and variable that can change. So while num is not equal to -1, and then num gets stored the value that we entered in the keyboard, if the user never enters a -1 in the keyboard, then this loop is never going to exit. So same types of syntax here with our while. Our loop control variable here is num. We initialize the 0 at the top, and then we read and modify it to see if we are going to enter the loop based on what the user entered in the keyboard. We actually check it, see if it is -1. Then in the body of the while loop with the bracket don't need to be there because there is a single statement, but I like to put them in there. Then we also read the next input and we restored in num. If the user enters a -1 for that text next input, it will jump out of loop. If they don't, it will continue to exit and ask them to enter information. A do while loop is a little different from the for loop. In the while loop, because it's considered a post test loop. So in the while loop, the body is executed while the condition is true. In the do while loop, where the body is executed for the first time unconditionally, then do while loop, because the test is at the bottom, means that you are always going to execute the loop at least once. You are always going to execute the body one time at least. It could be more, but it always one, it never zero, because the condition to test the exit is at the bottom. This is called a post test loop. It's called a control, called an exit control loop. So you would use the do while loop if you wanted the loop to enter at least one time. Typically, you don't need to use a do while loop, because you can still do the same thing in a for loop if you wanted to. You would just put the code outside the loop. So the do while loop is not really necessary, but there are cases maybe you want to use it after initial execution. The body is only executed while the condition is true. So after the first iteration of the loop, it's going to then act just like normal loop. It will jump out if the condition is false. So here is what it looks like. The do is at the top, and then the testing for the condition is at the bottom, and the while loop with the while keyword. So do is a new keyword. And then you are going to either have brackets or non-brackets depending on whether or not you have multiple statement in the body. If you only have a single statement in the body, you would not have a bracket. You will just have to do at the top, and then you will have the while at the bottom of the loop. And inside the while, the parenthesis, you will have the Boolean evaluation. That will be the condition that you check. But again, because that condition is at the bottom, you are always guaranteed to execute the statement at least one time. And so the example on the left is one statement and the example on the right is multiple statements. So you have the bracket, the curly braces, and again, in the second example, you are saying you may have something like prompt for password, read the user input, and while the input's not equal to password, but you are always going to prompt for that password at least one time. So another do while loop example, the first top example here is an example of how the loop may execute one time or many times, but never zero. It all depends on what the user enters. It's always going to execute at least once. But this is reading input from the keyword. We see the scanf function, and as long as the user does not enter 20, they will be executing this loop. A while loop can also be a counter control loop. That means it's going to execute a certain amount of times. In this case, it's going to execute 4 times. In this example, we have int number equals 4, and then we have 2 at the top, and then we have the brackets because we have multiple statements inside the body, and we are incrementing that loop control variable inside the body number plus plus, and then the condition for checking is still at the bottom. So you are going to execute this 4 times, and you will notice the while keyword does not have to be on the same line as the right curly braces. Typically, it's though, but it does not have to be. And the while keyword at the bottom two ends in a semicolon. You should also notice that. So we have learned all about these loops, the for loop, the while, and do while. What loops should you use? Well, first thing you have to decide on what loop you want to use is first. Do you want it to be pre-test or post-test? Do you want it to execute at least once, or do you not want to execute at least once? If you want it to execute at least one times, then you are going to use the do while. If that's not a condition, then you can use the for or the while or the do while. So for the most part, when you decide what loop to use, it's just a better option. In most cases, it's much easier to read. It's much better to look before you actually loop. Just don't start looping. Its loop is at the test. It's much more intuitive. So have that loop check at the beginning, use a for a while, and in many cases it is important that the loop be skipped entirely if the test is not initially met. Again, because that's the case, the test should be at the top. You should not always be executing at least once. For the most part, you always may not want to execute, so you should use a for a while. Now the question comes down to, well, which one should I use, a for a while? It's really a matter of personal preference. It doesn't matter, because like I said in the beginning of the lecture, everything you can do in a while, you can do in a for. Or if you just like the for while for loop better, the for is a little quicker sometimes, because all the loop controlled modification and the initialization and the exit condition can all be in one line. But it's really up to you. Typically, what I do is I will use the for loop for counter controlled loops. But again, you can use the same if you actually want to use a for loop and make it look like a while. You just don't have the first and the third expression. You just have the single one. So the for semicolon test semicolon is the same as while test. This is just showing you what a for in the while can do the same thing. Just change the syntax a little. If you want to actually use a while loop, but you want it to act like a for loop, then you would prefix it with the initialization and include update statements in the body. But this is the equivalent of a for loop. The initialization is outside the loop of the control variable. The loop control variable, the condition of test is inside the parenthesis. And then you are updating that loop control variable in the body of the while loop. And that's the same as the for loop initialization test update. And then the body, there's no difference. Again, as I mentioned, I use the for loop maybe for counter control loops a little bit more. But I will use both the for and the while interchangeably depending on how I am feeling that day. So for loop might be a little more appropriate if you want to initialize and update a variable in one line. A while loop is better when the condition are otherwise. Again, counter control loops for sentinel control loops, maybe maybe the while loop. And here's an example of a while loop with a sentinel control loop. And a for loop that's doing the same thing again, or a for loop for a counter control while loop can run many times based on what the user enters. The for loop is counter control. So this is the while on the do while. Hopefully this is clear because familiar with these loops because you often want to repeat code. The nested loops. There are times when you want to place one loop inside of another loop. It makes perfect sense. So for example, you might want to count the number of occupants in each house on a street. So what you would do is you would have an outer loop where you step from house to house. And then each house you are inside of, you would count the number of occupants. So I hope you can visualize or understand how that could be a nested loop. Again, the outer loop to go through all the houses, and then for each iteration of the outer loop, each house that you encounter, you would go inside the house and have a loop to count all the people. So that's kind of a little use case when you want to actually utilize a nested loop in C. Here's an example. It looks just like you think I would look a loop inside of a loop, really not too complicated. In this example, we are using for loops. For loops are nice because we can initialize the loop control variable, have our condition check and our modification loop control variable all in one line. So this outer loop and refers to it as the outer inner loop. The outer loop is exactly what it implies. It's the loop on the outside. And you can have many different layers of nesting. You could have in many inner loops. In this case, we are going through and it's counter controlled loop. We are starting at one and we are going all the way to count. We don't know what count is here. It doesn't matter. In the body of the for loop, we are saying sum equals 0. We are initializing the sum for the inner loop, and then inside the inner loop, we see another for loop for j equals 1. J is less than equals I and plus j. We then say sum plus equals j. We are calculating the sum of the integer from 1 to I. So what this is actually doing is you are entering a number 5. And for the first iteration of the loop, you are summing 1, 2, 3, 4, and 5. For the next iteration of the loop, you summing 2, 3, 4, 5. And for the third iteration of loops, you are summing 3, 4, 5, and so forth. So inner loops are necessary, especially just based on the use case, just a loop inside of a for loop perfectly. You are going to see it quite a bit. Don't shy away from it. Depending on what you need to do and what problem you are trying to solve, it's often used quite a bit. And to that point, it is not always a for loop inside of a for loop. You can have a while loop inside of a for loop. You could have a do while loop inside of a for loop. It doesn't matter. So in this example, same exact example, except now inside the body of the for loop, we have a nested loop, an inner loop called using the while keyword. So we are still calculating sum of integers from 1 to I. We have some initialization outside of the while loop. We have a condition inside the while check, and we have our sums inside the body of the while loop. Where we are modified, that's the loop control variable that we are modifying. So sum plus equals, and then we are modifying the loop control variable with plus j. So if we didn't modify plus j, we would have an infinite loop for the while loop. But it is doing the same output. It's just using a while loop as a nested loop instead of the for loop. So the nesting is not really any different from when you are nesting anything. You nested if statement inside of if statement, nested loop statement inside of loops. To get away from the nested loops concept, let's talk about the continue statement. Up until this point, when we have talked about loops, we have always executed the loop a number of times based on the exit condition, the Boolean expression that evaluates true false. However, there are times when you want to especially end a loop early, or you want to continue on the next iteration of the loop without you doing anything. In the latter case, continuing without doing anything, skipping, essentially, you can use the continue statement to do this. So the continue statement in the body of a loop does the following. And first of all, if you want to initiate this, all you have to do is put the continue keyword followed by a semicolon in the body of the loop. But what it's going to do is it's going to basically skip that iteration. So the continue, anything below the continue will not be executed if it's inside the body of the loop. So continue a lot of times will want to be at the top of the loop. Based on some condition, it's usually wrapped in an if statement. If this happens, a special situation, I don't want to execute any of the code in the body of the loop. Just skip this one iteration and check the next time. And again, it's a little confusing because you are skipping an iteration and you are jumping around, but it's valid and it's a way to do multiple checks. So even though you have your loop exit condition inside your Boolean expression, you can have another check, and that check is not going to jump out of the loop, but it's going to skip an iteration. So it's used again for the case when you want to skip iteration. The advantage of it is you can use continue and it will eliminate a lot of nesting. It will also eliminate a lot of additional if statement inside your block of loops. So it can enhance the readability when the statements are very long or you have deep nesting. So if you are doing a lot of nesting, you may want to say, oh, maybe I can use a continue instead. Or if you find that you have a lot of if statement that are doing certain things inside the body of the loop, maybe you want to do a continue. Don't use the continue if it's complicated rather than simplify the code. Don't use the continue if you don't know what you are doing. Here's an example of the continue. In this example, we are creating a new enum of type day. And we are saying that the valid values are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then we have a for loop where we are initializing our enum to Monday. And we are saying as long as day is less than equals to Sunday, that's a condition to exit. And then we are saying incrementing an enum. Well, remember that an enum under the hood is an integer. So you can say plus plus day on an enum, and that's just going to increment it to the next one. Remember, Monday is equal to 0, Tuesday is equal to 1, Wednesday is equal to 2. It's all the order of the list, so perfectly fine to increment enums. In this for loop, if it's Monday, Wednesday, we want to skip, we don't want to do anything, we don't want to print, we say continue if the day is equal to Wednesday, continue. It's going to skip the print line. It's going to go back up to the top of the loop, and it's going to execute the next iteration. And so it's then going to be Thursday. It's going to be equal to Wednesday, so it's not going to skip. It's going to go right down and print out it's not Wednesday. So this is a common use case, common example of using continue, very easy to use syntax. Just a simple keyword followed by the semicolon. Other use case, when you want to do something weird in the loop. So if you want to exit early, so normally after the body, the loop has been entered, a program will execute all the statements in the body of the loop. And for each iteration, and then it will check and jump out. And we know how the continue works, which is doing a little different script. There's another statement that can alter the execution of all these statements in the loop. It's called the break. And this should be somewhat familiar because we use the break keyword when we talked about the switch statement. Remember, when we had our cases, we would break out of cases that way. Well, you can also use the break keyword instead of a loop, and then this will do is it will just jump out of the loop. So the break statement is going to cause the program to immediately exit from the loop. It is executing statements in the loop are skipped and the execution of the loop is terminated. So you are just jumping out of the loop. You are executing early. If the break statement is inside nested loops, it's only going to affect the innermost loop containing it. You are only going to jump out of the loop that you are in, and do this you use the keyword break followed by a semicolon. Break is often used to leave a loop, and there are two separate regions to leave. So earlier I mentioned that you may have another region where you want to skip an iteration, but if there is two regions, two conditions where you want to jump out of a loop, you can use a break. If you only have one condition, then it's just a condition inside the loop itself, the inside the parenthesis, the loop, or before the second semicolon in the for loop. Break is also used in switch statement, as I mentioned. So I just wanted to remind you that don't get them confused. They essentially do the same thing, though the jump out of mode. Breaking a switch statement will jump out of that switch statement entirely. Breaking a loop will jump out of that loop. Well, here's an example. We have a while loop. We are printing out some integers. We are reading in some integers. We have a nested while loop. Inside the nested while loop, we check what was entered, and if it's greater than 100, we want to jump out of that inner loop. So we do. Then in the outer loop, we have to do another check. If it's greater than 100, we break out of that outer loop. If you didn't have second break, you would never jump out of the second outer loop. So in this case, this reminds me of a place where you could use a go-to imagine. If you had five layers of nesting, while loop inside a while loop inside a while loop inside of a while loop inside of a while loop, if you would just use the break to try to jump out of the loop, you would have all these if statements in each loop to jump out instead of doing all those if statements. You could have a goto. The goto would jump out of all the loop state loops in one single command. So that's the user case for a goto. But in the case, we are just demonstrating breaks and make sure you understand you are just breaking out of that loop that you are inside of. And in this case, we are breaking out of two loops. So these are the two examples, the two keywords where you can essentially not repeat code of what you expect it. So if you ever see a break of continue in the loop, make sure you understand what's going on, because you may not be executing certain code that you think is going to be executed. Again, usually wrapped inside of an if condition. So you can look at it that way, but you also want to provide good comments when you use break. Now that we are done talking about loops, let's apply them in a challenge. So in this challenge, you are going to create a guess the number C program. It's going to be pretty cool. It's going to be a little game. What's going to happen is your program is going to generate a random number from 0 to 20. After you have generated that random number, you are going to ask the user to guess what it is. So the user should only be able to enter number from 0 to 20. If they try to guess like the number 50, you are going to display an error and say, hey, you can only enter numbers from 0 to 20. So that's one stipulation. But once the user actually gets a guess and it's a valid guess, you are then going to tell the user whether or not they were too high or too low. Or if they were correct, you will display saying that they are correct and they will win the game. Now, they only have a certain number of times that they can guess the correct number. They can only guess the number 5 times. After 5 times, they lost the game. So this game is all about guessing the correct number, any number from 0 to 20. You want to validate the input from the user to make sure they entered 40 from 20. And if the entered something and they have less than 5 tries, you are going to tell them this was too high or this was too low than the number that they are supposed to guess. And those are the basic requirements of the program, a basic guess you number type game. Now, what the output look like? To give you an idea of how I designed it, you may want to follow this. When I first started the program, I displayed a little message. I said this is a guessing game, just so they know what's going on. I then told them I have chosen a number between 0 and 20, which you must guess. You have 5 tries left to guess. I then said enter a guess. They were supposed to enter their guess. they entered 12 and I printed out, sorry, 12 is wrong. My number is less than that. And then I displayed you have 4 tries left. Then they entered a guess of 8 and I said, well, 8 is wrong too. My number is less than that. And then they entered 3. I said they had 3 tries left. I entered 4. I said 4 is wrong. Then they had 2 tries left and they finally guessed my number, which was 2. Once they guessed the correct number, I told them, congratulations, you guessed it. So they won the game because they still had 2 tries left. It's a basic type of simple game where you are going to need to use if statement, you are going to need to use while loops. So you are going to need to use a loop in this because you have to keep asking for input until the user guessed correctly or until the number of tries was over 5. So one of the best ways to start a program like this is to write down how you are going to create the program on paper. And I would suggest you do that because if you write down how you are going to attack the problem on paper, it's going to easier to write solve. And you can write it out in pseudocode. So it's just English language, but you want to identify where you are going to have the loop and where you are going to have the if statement to check for condition. Because if you look at this output, there is many condition that you have to check for. The while loop is going to check for condition, or the for loop it's going to check to make sure that it exits loop if you guessed correctly, or if you are higher than 5 for try. You are going to have conditions to also validate what they entered. So you are going to have an if statement to say, hey, you just entered a number. And if it is not between 0 and 20, and that may be, you also may want to have a nested loop for that case, because you want to keep asking them to enter another number until the enter in valid number, not the correct number that you guessed what a valid number. So I could see for this program an outer loop. The outer loop would be the loop that asks the user to enter numbers until they have successfully guessed the correct succeeded their number of tries. I could see an inner loop where it asks if the number is not valid between 0 and 20. They keep asking the user to enter a valid number. And then I can see if statements to basically check whether or not the number is too low, too high, or equal, because you have multiple exit condition for your outer loop. Whether or not you guessed correctly or whether or not the numbers equals, that may be a good case for using a break statement, because remember, you use the break statement when you have multiple exits. And so you could have something inside your outer loop that says if they guess correctly, jump out. And then the condition in the outer loop itself, in the while loop or the for loop itself, the condition X, it would be whether or not the number of tries is greater than 5. So that's one design approach. I mentioned many things. The only thing left, you have everything at your disposal. If you learn it, everything I mean, except this random number generator, this is new. You know how to if statement, you know how to do loops, you know how to declare variables, you know all these nice things. You know how to print output to the display, but you don't know how to do a random number generator. You need to generate a random number because each time you run the program, you want to have a new number that they can guess. So to generate a random number from 0 to 20, these are the steps that you have to follow. First, you have to include 2 additional libraries, the stdlib.h, time.h. So you want to add these include directives at the top of your file. stdlib.h will allow you to use the function which allows you to generate random numbers. Time.h allows you to provide the seed for the random numbers using the time, getting the current time. So when we include additional libraries outside of our program, it just means we want to perform some additional functionality. We have not talked about all the standard libraries that C comes with, but they come with 2 nice ones to get the current time and also to generate a random number that we are going to use. So we include those first 2 directives at the top. Then we are going to create a variable inside of our main function called time t, and you can just name it t. You add that. Once you add your time variable, you can initialize your random number generator using the srand function. So what you do is you say srand. This provides a need to random generator seed. It's just used to initialize it, and here you just copy this line of code sren unsigned and then time, and then you pass an m%t. Don't even have to understand what this code does, just copy and paste it. But it's generating a random, it's initializing the random number generator. After you have initialized a random number generator, you have to generate the number. And all you do to generate the number is you say rand. You call a function named rand and you say %21. That's a module because you want it to be between 0 and 21. You use integer 21 hard coded. You can store that random number in an integer, and that's the number you are going to compare against to exit the loop, whether or not the guess correctly. It's also going to be the number that you compare against to determine whether or not you print too low or too high. So this should be a lot of fun. Again, a lot of concept you are going to be exposed to. If a statement, looping constant, the break statement, inner and out